come watch me and Michael fight. That's like great, right? We always lie on time. We'll just start laughing.
Leprechaun.
Linear inequality.
Alright, I'm going to get my graph paper going.
Linear inequality.
Yeah. In two variables. You don't necessarily have to write that much of it. Alright, first thing that we got to look at here, this first line that we're going to graph says x plus y is less than or equal to 4. Okay, that's what makes this different than the lines that we've been graphing just normal, is now we've got an inequality. We're greater than, less than, greater than, equal to, less than, equal to. Remember when we graphed a number line? When we were greater than or less than, there was shading involved. With a shade on number line. Same thing here in the XY. We've got to do some shading. This is where it gets really messy and we do some scribbling, okay? First off, let's just graph it, pretend like it's a normal line, like it just says x plus y equals 4, and let's graph it like normal. Your options for graphing that, you can rewrite it in a slope-intercept form, wouldn't be hard to do, or you can plug zeros in, not hard to do. This one, I think the zero method's easier, because it's both just ones. If I plug a 0 in for y and take that out, x is 4. So there's my x-intercept. If I plug a 0 in for x and take that out, y is 4. So there's my y-intercept. Okay, now I haven't drawn my line yet for a reason. I want you to think, I got a couple options for you here. I want you to think if I should draw my line as a solid line or a dashed line.
Solid.
Okay, solid because we've got the equal bar underneath it. So if it's just greater than or less than, now we're going to have a dashed line. If it's got the equal bar underneath it, it's going to be solid. Okay, so I can go ahead and connect them now with a solid line. Oh, and there I picked a dashed one. I had that from last time, I guess. Okay, did pretty good that time. Alright, now, x plus y does not equal that. X plus y is less than that, so we got a shade now. This one is pretty easy, pretty obvious to tell, because we know that less than normally means left or under. So it should be fairly obvious to tell that this is the place we got a shade, but sometimes it's not obvious. So we got to have a foolproof plan, and it's going to be to plug in a test point. So I'm going to plug a test point in to that inequality, work it out, see if it makes it true or not. Okay? Easiest point, it can be any point on this entire graph as long as it's not touching the line, because that one you would just be running in circles every time. So easiest point, as long as your line doesn't touch it, is 0, 0. So I'm going to plug a 0 in for the x and a 0 in for the y. If I get a true statement out, that means 0, 0 is a part of my answer, so I'll shade this side of it. If I get a false statement, that means 0, 0 is not part of my answer, so I can't shade here, which would mean I shade over there. Okay, remember that from a while ago, Algebra 2 age, Algebra 1 age also. So let's go to the top there and plug my 0, 0 in. 0 plus 0 is less than or equal to 4. Well, that's pretty much a no-brainer, right? We know 0, bless you, is less than 4, so it was true, so that means that's the side I shade. So that whole big, ugly, scribbled on graph is my answer. Yep. And just wait, they're going to get even uglier in a little bit, because we're going to have two of them overlapping.
Thanks for telling me that.
I know. I always want to call Miss Cook and show her some art. Somebody buy it and hang it in their bathroom. Alright, let's look at another one. I've got 3x plus 4y is less than 12. Okay, 3x plus 4y is less than 12. So again, you got choices on how you can graph. And if you like graphing out a slope-intercept form and you want to solve those for y over time, you can. I don't have a problem with that. I just know that this one also is going to be easy using zeros, because 3 and 4 are factors of 12. So this works out some good whole numbers for me. So look what happens if I plug a 0 in for y. If I take that y out, I've got 3x is equal to 12. So that means my x-intercept is 4. 1, 2, 3, 4. Been having a lot of 4s already today. If I take my x out, if I plug a 0 in for x, that gets me 4y is 12, which means my y would be 3. Alright, now is the line that goes through these points going to be solid or dashed? Dashed, good, because there's no bar underneath the less than sign. So this one's just going to be a good old dashed line. Okay. Now I've got to figure out, do I shade above it or below it? I'm going to use my same test point, so I'm going to plug zeros in, 0, 0 in. 3 times 0 is 0. 4 times 0 is 0. Is 0 less than 12? Yes. Now don't think that just because we've done 2 that the test point was true that they're all like that. If that had been false, I would have scribbled up here, right? Everybody okay on that? Good stuff, good stuff. Alright, we're going to look at somewhere we got an overlap now. Got a line that says x minus y is less than or equal to 4, and this is going to be important, and x is greater than or equal to negative 2. Remember, ands and ors are important when we have greater than less than symbols. And is an intersection. That means I'm going to be looking for overlapping. An or is a union. That means it can be anything at all. Keston put it up. So this one is overlapping. Alright, let's go ahead and just solve this. Either way you graph it, either way you want to. I'm going to plug zeros in again. And good grief, we're having 4s to death right now, aren't we? If I plug a 0 in for y, that gets me x is 4. If I plug a 0 in for x, that gets me negative y is 4, which means y is negative 4.
Is that a quarter of y on the other side of it?
4. So y is negative 4. So I'm way down there at the bottom. Alright, so do those get connected with a solid or a dashed line?
Solid.
Solid, Kaylee's right, because it had the equal bar underneath it.
There's a lot of 4s.
I know, it's been 4 bonanza today, hasn't it? Alright, so now I'm going to use my good old favorite 0, 0, test that out. 0 minus 0 is 0. 0 is less than or equal to 4. So I'm shading up there above the line where 0, 0 is. Kind of going a little bit more crazy than normal, exaggerating this because I'm going to have to put another line on there in a second, right? Okay, my other line. You ready for that? Maybe the red will show up. X is greater than or equal to negative 2. So I'm just going to move to negative 2, which is right there. Can you see that? What kind of line will this be? There's not a Y.
Vertical.
Vertical. Okay, it's going to be a vertical through there. Is it going to be a solid or a dashed vertical line? Solid. Good. So let's see if I can get a solid red line to go with my red here. Okay. Now, this test point's not really needed on this one, right? X is greater than that. That's pretty self-explanatory that it has to be the right of that red line, right? So I'm going to shade everything on the right of that red line. Okay. Now my answer, this was an and I told you that was important when we wrote it. Since it's an and, it means an intersection. So my answer is going to be every part of that graph where my black and my red overlapped. Okay, it's fixing to turn magical highlighter yellow for me. It's going to be green, my bad. It's going to be everything where I have red and black, both, which makes green. Y'all just didn't know that. Another reason we need Miss Cook to come in here and tell her how to make green. She'll be like, what is wrong with you? Don't worry, my students already know.
I'm gonna try to come in here tomorrow.
No, we'll be doing it tomorrow. I don't know what we're doing tomorrow. I have to look. The red kind of went away in there though. You can't see the red anymore, can you?
There's a little piece next.
Yeah, well, I missed you. Alright, difference in the and the or. And's the intersection. It's the big section where they overlap. Or means it could be in either one of them, so it doesn't have to be overlapping to be in an or. Okay, let's look at one of those. Everybody okay on this? You have done this before. Algebra 1 and Algebra 2. It's just been a while. Alright, here we've got 7x minus 3y is less than 21, or x is greater than 2. 7x minus 3y is less than 21, or x is greater than 2. Alright, the 7x minus 3y equals 21, that one. We're going to keep that, or I'm going to keep that like it is and just plug zeros in because 7 and 3 are factors of 21, so that's easy to do. If I plug it, I'm going to have to count on every line this time, so it's going to be like 1, 2 because I don't have 7. When I plug 0 in for y, I get 7x is 21, which gets me an x of 3. So it's going to be 1, 2, 3. See, I'm counting on every line this time. When I plug a 0 in for x, here's y, it gets me negative 3y is 21, which means y is negative 7. Okay, so I'm going down 1, 2, 3, 4, 5, 6, 7. Alright, so let me look back at the equation because I forgot. Okay, I see. Is this a solid or a dashed line?
It should be a dash.
It's going to be a dash. Zane is correctamundo, so let's connect those with a dashed line. Okay, I'm going to use my favorite test point. First period thought we should use 0, 0 over time. That will always work. As long as your line doesn't go through 0, 0, it will. Okay, so let's go plug 0, 0 back in. 0 minus 0 is 0, and that's obviously smaller than 21, so we're shading where 0, 0 was. Okay, everybody all right on the first line? You could graph that by yourself. Fantabulous, right? Okay, now we've got a second line, x is greater than 2. So I'm going to go 1, 2. I'll be right there. What kind of line is that? Horizontal or vertical, solid or dashed?
It could be dashed.
It's going to be dashed. Is it going to be horizontal or vertical? Vertical, so I'm going to have vertical line through that. Greater than 2 goes to the right of that. So I'm over here. All on the right. Get up there in that business sum. Down here in this business sum. Okay, now this one was an or. That's important. If it had been an and, I got a real small section that overlaps. Look, can y'all see my mouse going crazy? Right in there where my mouse is going crazy is the only place that an and would be found, right? This one says or. So it's anything that's shaded at all. So my answer on this one is going to be everything except that little piece on the bottom that didn't get shaded. So everything that's black, everything that's red, everything that's black and red. The only thing that's not part of my answer is right here where my mouse is, where nothing got shaded. So that's a difference in ands and ors on that. Beautiful, huh? Bathroom art. Somebody in first period said you could sell that for $9.99 at TJ Maxx.
I could do some mustard.
Alright, you got to try to graph one by yourself now. I'm just going to give you a single. Everybody done with that?
I'm in.
Okay. Alright, I want you to try to graph 4x minus y is less than 4. Okay, graph and shade on that one, and we'll check that. Then we got one other thing left to do. 4x minus 4 is less than y.
minus y or minus 4?
Minus 4. 4x. Oh, hold on. Hold on.
4x minus y.
I said y when I wrote it the first time. It would almost have to be. Yeah, that's supposed to be a y. Sure does look just like my 4. Usually a lot of people ask, but I can tell the difference. That time it was bad enough that I couldn't even tell. That's
Yeah.
I can tell that's a y.
No way, bro.
This morning we were doing the same lesson, obviously, first period, and first period is full. I think I got one empty seat. So I use the cards a whole lot for them to call on people. It takes me too long to do it for y'all because I'll draw all those people that don't sit anywhere, you know. But so anyway, I drew a person's card and so they had to go to the board to do it. And they started dotting their line and they were like,
Yeah,
and I was like,
that's about
finally
what
somebody has a worse line than me. It was good. We clapped for her. She got embarrassed.
Like that, then
I want to try that.
Well, she went up there. She didn't try here. All right. I know. I've got my line connected.
My line looks like your line.
Atta
so
boy.
does mine.
Atta boy. What do y'all think over here? Everybody good? I had a y-intercept of -4. When I plugged the 0 in, that got me negative y was 4, so I divided by -1. I had an x-intercept of 1. When I took my y out, 4x was 4, so I divided by 4, and I was at 1.
Yeah.
Okay? Now I got to test where to shade. I'm going to stick with 0, 0 as often as I can. 0 minus 0 is less than 4. Okay, so I'm over here because it was true. Now, I know I'm spoiling you because everyone that we've done so far, the test point was true. It's just a bad coincidence. That's not always going to be the case. If I'd have had something here that said 0 is less than -4, that's wrong, right? So I would not have shaded 0, 0. I would have shaded over here. Do y'all follow that?
Yes.
Okay, just got to make sure. All right, last thing we got. I got some weird questions to make you think about it in a different way. So let me find where I'll put my book. Do some mental math type stuff. If I had the inequality that said y is less than or equal to -x plus 2. Okay, the first time I read the problem to you, because we're going to do about 4 of these that are the same choices, so I'll give you the choices after that. You'll just have to remember them. The directions, the question says the boundary of the graph of y equals -x plus 2 will be a blank line, and shading will be blank the line. Okay, so here's what the choices are for that. The boundary of the graph of y equals -x plus 2, or y is less than or equal to -x plus 2, will be a solid or a dashed line, and the shading will be above or below the line. Okay? Solid or dashed, I think you probably know just by looking at it. If you don't know above or below, you might need to draw you a graph real fast and figure it out because I'm fixing to call on you. Okay? So solid or dashed line, shaded above or below the line. If you are doing a quick graph to check it, that's in slope-intercept form. So this is a time when I finally would not do zeros. It's got a y-intercept of 2 and a slope of -1. I would just graph it like that. Okay, so if you can figure out solid or dashed line, shading above or below, and I'm going to call on somebody here in just a second. Alright, so the boundary for that line will be solid or dashed. Aaron? Solid, because it's got the equal line underneath it. Everybody okay on that?
Yep.
Okay, the shading for that line will be above or below. Caitlin?
Below.
Below is correct. How'd y'all do? Everybody need to see it? Need me to draw it? Are you good? See it? Okay, let's look here. If I had a y-intercept of 2, I would be there. A slope of -1, I would go down 1 and over 1. So there's my solid line. See, that's my line there, Michael. There's my solid line. Now, I'm going to test 0, 0 still. It's just a little bit different because it's not in standard form. 0 is less than or equal to 0 plus 2. Yep, 0 is less than 2, so it's shaded below it.
Oh, so you're not trying to get the point to be like, see how it's negative, it's not supposed to be on the left side, it's just supposed to make a negative slope.
Right,
Okay,
right.
that's what it was.
I got you. All right, same type of question now. I'm only going to change one little thing in the inequality. This time I need to know the boundary of the graph of y is less than or (x plus 2) will be blank. The shading will be blank. I only change one little thing. The boundary will be what kind of line? The shading will be where? What kind of line will it be, Caleb? Dash, because it doesn't have the bar.
Yeah.
Where will the shading be, Kirsten? Stays in the same place. We didn't flip the sign, did we? So it'll still be below. Kirsten's correct. Very good. All right, now, change one little thing again. Now I want to know what the boundary of y is greater than (x plus 2) will be. What will that boundary be, Hayden? Solid or dashed? Dash, okay. Do you need to think a second? This one's got to change. That pretty much gave you the answer. The shading will be, Michael? Above. Very good, because we turned the sign, which made 0, 0 false, right? So we had to shade above. Okay? All right, last one. The boundary for that line will be solid or dashed. Dustin?
Solid.
Solid, correct, Mundo. The shading will be above or below, Hunter?
Above.
Above is good. Everybody all right? Okay. I tried this morning to think of what a good exit question like this would be, and it would pretty much it would have to have been one of them that we did because we can't draw these graphs in our classroom, so I gave up and just didn't do one. Yeah. So lucky on that, didn't get one. Tomorrow we go to functions. Okay, functions are linear. You still got some free time though. Yeah. Yeah.
But I